Hey, let's do this. 4.1, we're talking sampling. So we're kind of in this whole new like collecting data realm. We've been doing all this calculation on data, but the question is it any good? So we actually need to make sure that we can actually get good data. And so that's what we're going to be kind of focused on today, is doing that. So 4.1, sampling. So let's look at the sampling. First thing that we want to talk about is like when we sample, what does that even mean? So what I want you to consider is things like this giant population, right? We're going to call this our population. Now, population can be super big, like the United States, like all the people in the United States. Or the population can actually be kind of small, like this period of statistics, these 20 students, right? And it doesn't matter which one it is, but the population is the whole group, right? So we kind of call that the whole group. And then sample is just going to be a section of it. So we're going to call that the sample. And we're going to call that a subset of the group. Now, ideally, you want that sample to be representative of your population. But the problem is we all mentally have our own idea on what is representative of that population, right? So some people might say, you know what, I think it needs to have a certain amount. Let's say we're talking about people. Let's say we're talking about the state of Oregon. It needs to have a certain percentage of Caucasian, certain percentage of Latinos, a certain percentage of African American, a certain percentage of Native American, and so on and so forth, right? So this is what people think, and they say that's representative. But then also people think it needs to have this type of person, it needs to have this kind of business person, it needs to have this, right? So then also know we're all convoluted on what is it that actually is representative of a population. So we don't want to get all in our heads about that. We don't want to try to figure out like, what is that sample? I'm going to take that on and tell you what the sample is. No, because we have preconceived notions on what that is. So we don't want to do that. So instead, what we're going to do is we're going to take on, in order to get this sample, the subset of a group, we're going to take on some kind of sampling techniques. And we're going to use a thing called a random sample technique. So random sample. So I'm not going to leave it up to you or me. I'm going to leave it up to chance. So our basic random sample technique that we like to go with is called an SRS. And that is short for a simple random sample. Simple random sample. Imagine this is a classroom of 20 people, and I take all the names and I put them on equally sized sheets of paper and I stick them into a little bowl. I shake them up, and then I pull 5 of them out. Now the 5 of them represent the sample, and the 20 of them that were in the bowl represent the population. But simple random sample is literally stirring up the hat, stirring up the bowl, picking out 5, and those 5 people, those are the people I talked to. I left it up to chance, right? Simple random sample. It gives everyone an equal chance to be selected. But it also gives any group an equal chance to be selected. So of selection. So what that means is like any group of 5 pieces of papers that I pull out of there have a chance to be selected. I have not narrowed my scope. I have not said, hey, once one is drawn, and it happens to be a kid in 11th grade, no more 11th graders can be drawn. No. We're not saying that. It could be a group of 5 11th graders. It could be a group of 5 9th graders, right? Whatever it is, if there were ninth graders in the class. But you get me, right? So that it's a bowl full of 20 slips of paper. Every single paper has an equal chance to get selected, and any group of 5 that you think you can put together has a chance to be selected, right? I have not given that. Simple random sample, right? So that's exactly what it is. So think about Lake Ridge High School. Let's say Lake Ridge High School is the population. And so what we do is we number off all the people in Lake Ridge High School, right? We just number you off. Everybody gets a number. Let's say N equals 1,200, right? There's roughly 1,200 students. I'm just going to use ballpark numbers right now. And then I'm going to go and I'm going to take a sample out of there. I should use a capital N. Capital N stands for population size. And I'm going to take, let's just say I'm going to take 100 students out of here, and I want to ask everybody a question, right? So that is taking a sample, asking questions, let them go back about their business. So I would put them all in a hat, pick them out, and got the numbers. Or if you got numbers, use a random number generator, and then that would pick them out for us as well. Okay, so that's random sample, simple random sample. Another strategy sometimes we like to use, it's called a stratified random sample. Right? So a stratified random sample, it does something different. It puts individuals into groups of known likeness. And then number 2, take a simple random sample from each group. Okay, all right. So here's the deal. I think I see something, I'm like, oh man, I need to get equal representation from all these different groups, and I do not want to miss it. Because guess what? Simple random sample up here, right? Simple random sample, you could do a simple random sample, Lake Ridge High School students, 100 students, you could get all freshmen. What if my question was, I want to know what percentage of students drive to school? I got freshmen. All 100 freshmen said, I don't drive to school. So I use those results to talk about the population. I'm like, you know what? I took a sample of 100 students here at Lake Ridge High School. Zero students drive to school. How crazy is that? No, that would be crazy. Simple random sample has its flaws, right? If we need equal representation from certain groups, then what we need to do is break the population into the groups and then go take a little subset out of each of those. So how would we do stratified random sample? Let's say it's Lake Ridge High School. Let's say that was our question. We just needed equal representation. We still got Lake Ridge High School. So what I'm going to do, I'm going to put everybody together. So we're going to have you 12th graders, you 11th graders, you 10th graders, and the 9th graders, right? All in their own little groups. And then if I still, we're still talking about full population size of 1,200, and I still want a sample size of 100, well, if they're equal, they don't always have to be equal, but then we'll just take like a little equal simple random sample. We'll take a simple random sample of 25 out of the here. Take a simple random sample of 25. Sometimes you do this proportionally. So if one of our classes is a lot bigger than another class, then we might take a little more out of that class and a little less out of a different class and still try to get up to that number that we're looking for, that global number of 100. So this is called a stratified random sample. Break the population into known groups ahead of time, go into each group and take just a little sample out of each group. And then we're going to combine those back together for my full sample of 100. Now I got some equal representation from groups that I was afraid I was going to miss. Simple random sample, you might miss them. Stratified random sample, and now I got them. All right, so that's called random sampling techniques. Those are 2 that we like to use a lot. Hey, let's look at a third one. Third one is called cluster sampling. So cluster sampling, here's what we're going to do with this one. Break into easy to define groups. Number 2, take a simple random sample of groups, then number 3, select all individuals in those groups. Okay? What does that look like? What are we talking about here? We're talking about Lake Ridge High School. Let's say you went to Lake Ridge High School in a normal year, right? 1,200. And we had all these classrooms, right, going on in a certain period, right? So I'm going to go and there's these classrooms. I know this isn't the true blueprint of Lake Ridge, although it's probably not too bad, right? That's pretty close to what Lake Ridge looked like from an aerial view. But anyway, let's say we went into Lake Ridge High School and we had all these classrooms and we got students in them, right? So there's some in the math classes, there's some in English, there's some in social studies, there's some in world languages, there's some in PE, there's some in ceramics, right? They're in all these different rooms. So I'm going to go through and I'm going to label each room 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on, right? I would just number away. And what I'm going to end up doing now is once I have every single room with its own unique number, right? They all got their own unique number. Now I'm going to do a simple random sample from 1 to 30. And I'm just going to pick a couple different rooms, right? Just a couple different rooms. So let's say I picked, let's see, I did a random, like I put them all into the bowl with numbers 1 through 30. I pulled it out. Hey, it's number 5. Okay. Let's pull out another one. Hey, it's number 16. Okay, let's go to number 16. Let's do one, let's see, about 25. Let's do 2 more, right? So we reached in, I get number 2. Let's reach in and let's say I got number 29. All right, so there it is. So I would only visit those 4 classrooms and I would sample everybody in those classrooms. Now, it might not be the exact magic number of 100 that maybe I was looking for above. It might be a little more, a little less, but maybe it's going to be close to that. That's kind of a target number. And I would just interview that. So everybody else in every other classroom, you didn't get a chance. You didn't get a chance to be named. So therefore, I would take that, and that. Take those people, interview them all, and get them. Now, what's the flaw in that, in cluster sampling? It's very much like random, simple random sample, is I could end up getting all freshman classes. All 4 of those could be freshman classes, and it won't help me accomplish my goal. But what is the advantage of that? It's fast. I get to take random groups. Simple random sample it takes a long time. It just takes a long time to track everybody down. Stratified random sample takes a long time. It takes a long time to track everybody down. Cluster sampling, it's efficient. It's fast. It still uses random chance. It doesn't use my own thoughts and abilities. And that's what it is. So that's going to give you the different random sampling techniques that we're going to kind of use in this class right there. So what do we need to know about random sampling? What are we doing? So first of all, we are doing a thing called surveying or sampling. So we're doing survey or sampling versus experimenting. So survey or sampling, that is literally where I'm doing this technique right here. I'm finding people and I'm asking a question. Hey, what did you think about the debates? Hey, what color are your shoes that you're wearing? Actually, I don't even need to say that. I'm just going to look. That's called an observational study. I'm observing something. But it's something where I am just going and I am collecting data from individuals. I am not trying to influence the response at all. Experimenting is when you actually go and you try to influence response, right? You go find people and you say, hey, I want you to do something and I'm going to observe the response, right? So you're going to force what we call a treatment on people, right? So right now we are in the world of surveying and sampling. Later on in this chapter, we'll get to experimenting. So just know that we are not trying to influence the result. I'm doing observational study. or just asking straight questions or making you fill out a survey or something like that. That is sampling. That's what we're doing. That's what we're after. But so I do these random sampling techniques to try to curb what we call biases. So a bias. So really, what is it? What is a bias, right? It is when we systematically, so that means something that I did, systematically draws answers and leans it towards one response or another, right? So systematically leads individuals toward a response, right? A certain response. So it's a bias. Oh, I didn't even say bias. It's a bias, right? Systematically leads individuals to response. So let's talk about a couple biases we want to avoid. Number one, a voluntary response. Bias. Voluntary response bias. That's where I let people respond if they want to my survey. I'm going to go set up in the middle of the senior commons at Lake Ridge High School with a table says, come over and take my survey. You, as a walker by, get to choose whether you take my survey or not, right? That's voluntary response. Voluntary response is also, I go into a restaurant, I eat dinner, and at the end, they leave me a comment card, right? So I can choose to do that comment card or not, right? So that is a voluntary response. A lot of times the comment cards will just be in the middle of the table, and like I can fill it out if I want. But those are voluntary response. Voluntary response, or when somebody's standing on the corner, I'm like, yeah, do I want to go talk to them about their survey or not? That's voluntary response. What does it do though? The people who do voluntary response have an extreme opinion, one way or another, right? So what it does, it gives us the extreme responses. It's usually not the bulk of the people that we really want to know about. It's the people who care enough in order to do the actual response. So we call that voluntary response. A second type that can be a bias is called a convenience sample. A convenience sample. This is where it's just really convenient. So I want to know what the average GPA of Lake Ridge High School is. So I'm going to ask you guys just this class. It's pretty convenient. You guys are all here. Or maybe I'm a coach of a football team and I decide I'm just going to ask my football team, like, what's the average GPA? And I'm going to use that. Convenient, right? Or I'm gonna go. I'm just gonna, I'm at the end of a Blazers game. I'm walking out. I just want to ask. I want to find out what are people's favorite NBA team. It's convenient. Problem with convenient samples is that you get a lot of similar responses. Go to a Blazers game, you're gonna get a lot of people that say, "Hey, I'm a Blazers fan. Blazers." I ask people in AP stats, I'm going to get a lot of AP stats driven GPAs. I asked a lot of people on the football team, I'm going to get football team responses, right? So I get all of those different things, but they're very much alike, right? So we call those biases, right? They are systematically leading us towards a response, right? So that's what those are. Let's talk about like some sampling errors that happen. Sampling errors, right? These are a little bit different. They're still kind of under this realm, like they still lead to some bad answers, but they come from the act of choosing. So sampling errors are the act of choosing our sample. So it is, again, it's a systematic problem that we can actually fix. Voluntary response, we can fix. Simple random sample. Convenience sample, we can fix. Simple random sample, right? We can fix these systematic problems, right? Sampling errors here. So I'm just going to keep the numbers going because they're all problems that we want to have to deal with, right? One of those is called undercoverage. So what is undercoverage? It's when you go out and you seek individuals, but you miss a part of the population. I'm going to do telephone calls. What if they don't have a telephone? What if their telephone number's unlisted and I couldn't get it, right? That is an undercoverage, anybody without that. What if I go door to door, go knocking door to door and ask people polls, right, on like a local, who's going to be local mayor, right? But what happens if people are homeless? We missed out on that, right? We don't get them at all, right? Undercoverage is when we miss out on a part of the population, right? Whether knowingly or unknowingly, we have an undercoverage, right? So what it does is it inflates some of our responses, right? So if I have an undercoverage and I miss out on people with telephones or that have unlisted numbers, what do the people with unlisted numbers think? It inflates for the people who have listed numbers, right? Things like that. So undercoverage is a big deal that we need to deal with. And then let's talk about non-sampling errors. Non-sampling errors. These come from not so much in the act of choosing the sample or the system that we chose. They come from a really good design, right? But it has nothing to do with the way that we chose the sample. So take, for instance, this one right here. It's called a response bias. So response bias is because it's me, right? So I'm going to go up to a student at Lake Ridge High School and I'm going to be like, what's your GPA? Because it's me, they might inflate that number a little bit. They're like, it's a 3.9, right? So response bias is a problem that comes with the interviewer themselves, who they are, what they're saying, how they're asking a question. It influences the response. Influences the response. One of the most popular type of response biases is called the wording of a question. The wording of a question is a response bias and it's a very popular one. It's the way that you word a question that kind of leads or influences the response into something, right? So we say something like, I don't know, let's go with, Donald Trump has kind of seen the biggest decline in the economy since the end of the Obama administration. What do you think about the presidency, right? So it's leading with a word in front to try to suggest a certain response on the back end, right? So it could be certain things like that. It can be small things like, instead of just saying like, I want to find out what percentage of Lake Ridge High School students work out. So the question is, do you work out? But then if I put in a question like, do you even work out? Right now, people feel entitled to like, hey, whoa. Do I even work out? Yes, I work out, right? So it leads us to a certain response and it gets us there. So wording of the question is a type of response bias. But response bias could be anything. It could just be me because I'm asking it. It could be because we are asking a question that's a little bit taboo to be asking, right? So if I went to Lake Ridge High School and I said, have you ever smoked pot? That's a question that's a little bit like, whoa, I better answer this in a way that if somebody finds out it's me answering it, that I'm gonna be okay, right? So it can lead us to the wrong answers because we let it on accident, or sometimes we do it on purpose, especially in political times we'll do some things on purpose to lead people to answers so that we get the right data that we want. Doesn't make it the correct data, it's the data that we want. So it's called a response. And then finally, the last one is non-response. Non-response, so again, kind of under this idea of it's a non-sampling error because these things can happen even in a great random sampling technique. But non-response is when you go to get, like I have your name, I'm coming to ask you a question and you choose not to answer it. Now that's different than voluntary. I didn't just sit back and say, come ask or come fill out my survey. I handed the survey to you and I said, fill this out, but you decide not to. That's non-response. Or I call you and you hang up on me when I say, hey, I'm here to do a survey. That's non-response. Or I go knock on somebody's door and they're nowhere to be found. Non-response. That's non-response. So in that sense, we leave out on some answers that we really, really, really wanted, right? And we didn't get it. So those are different types of errors that we end up with here. So these are the kind of things that we want to kind of talk about. Is number one, what is the sample? It's a part of the population. It's not the whole group, but we want to get it as representative as we can. So we can't rely on my own mind. Got to rely on chance. And we call that random chance, random sampling, simple random sample, stratified random sample, cluster sampling. Those are the ones we're going to really focus on to try to get really good data on this thing. And what we're going to try to avoid while we're doing these samples is these kind of biases and other kind of systematic errors. Voluntary response bias, convenience sample, undercoverage, response bias, and non-response bias. Right, so I actually want you to know these things by name because they come up by name a lot. But voluntary response, convenience, undercoverage, response, and non-response. Right, so know those different kinds that you do. All right, that's kind of 4.1, kind of packaging in there a little bit. We'll do some problems on that, and then we'll move on to 4.2.